So today we're going to continue with the last section on measurement and calculations. We'll look at temperature conversions and density. So first let's look at some temperature conversions. There are three main temperature scales. Fahrenheit, this one is used in the US and Great Britain, so we always put a degree F. And Fahrenheit is also used in most engineering sciences. Water boils at 212 degrees Fahrenheit and freezes at 32 degrees Fahrenheit. The next temperature scale is the Celsius scale. This is used in Canada and Europe, and it's used in mainly physical and life sciences. In degrees Celsius, water boils at 100 and freezes at 0. The third temperature scale is Kelvin. This may be one that you're not as familiar with. Kelvin is different because it has what's called an absolute scale, which means it will never be negative, and that can be kind of convenient when it comes to calculations. It's said that absolute 0 in Kelvin can never actually be reached because at 0 Kelvin all particle motion would cease, and so basically all life would cease to exist, kind of type thing. Kelvin is used in all sciences, and in the Kelvin scale, water boils at 373 Kelvin and freezes at 273 Kelvin. The other thing that you should notice is that there's no degree symbol on Kelvin, but there is a degree symbol for Celsius and Fahrenheit. Okay, so what we need to be able to do is convert between temperature scales. So the size of each temperature unit is the same for Celsius and Kelvin, and the difference between their freezing and boiling points is 100. So every degree is the same amount, it's just we have different starting places. Fahrenheit is a little bit different. Each Fahrenheit degree is smaller than a Celsius or a Kelvin, and instead of there being a 100 degree difference, there's a 170 degree difference between freezing and boiling, and so that's why we have smaller degrees for Fahrenheit. What's also different on all three of these is what's called the 0 point. So the temperature at which water freezes is different for all three of these scales. Since converting between Kelvin and Celsius is easier, let's start with that one first. In order to convert from Celsius to Kelvin, we add 273. And then here's our equation. So temperature in degrees C plus 273 gives us Kelvin. We can go the opposite direction and subtract 273 from Kelvin to get degrees Celsius. So let's look at an example. So the boiling point of water at the top of Mount Everest is 70 degrees Celsius. We want to convert this to Kelvin. Okay, well we know that degrees C plus 273 gives us Kelvin, and so we take our degrees C plus 273, and that gives us 343 Kelvin. Okay, so let's just talk about this for a second. If the boiling point of water is normally 100, do you know why the boiling point at Mount Everest is 70? Well, it's due to the higher elevation and the lack of air pressure. And so that's why here things will boil around like 94 degrees Celsius versus 100, and that's why like a lot of baking and cooking and other things like that you have to modify because things are going to boil at a lower temperature. Okay, let's look at another example. Liquid nitrogen boils at 77 Kelvin. What is the boiling point of nitrogen in Celsius? And so we know if we want to go from Kelvin to Celsius, we have to subtract 273. So we take our 77 Kelvin minus 273, and it gives us negative 196 Celsius. Well, if you've ever done anything with liquid nitrogen before, as soon as you put it on something, it instantly freezes because it's boiling at such a very, very cold temperature. And so if you've ever seen like where they pour liquid nitrogen on a flour and then like hit the flour on the counter, it shatters because it instantly freezes. And so that's because it boils at such a low temperature. Okay, now let's talk about converting between Fahrenheit and Celsius. Well, Fahrenheit to Celsius involves a little bit more conversion because the degree units are different and the 0 points are different. With Kelvin to Celsius, we were just adjusting for the difference in where they started because the degree sizes were the same. And so we can look at the freezing and the boiling points of Fahrenheit and Celsius. Okay, and then if we take the difference between those, we have a difference of 180 versus a difference of 100. And if we compare those, we get that every 1.8 degree Fahrenheit is 1 degree Celsius. So that's how we're linking them together. And then basically we take that account for that difference plus the 0 points, and we get Fahrenheit is equal to 1.80 times the temperature in Celsius plus 32. Instead of using 1.8, if you wanted to use 9/5, that's fine. Both equations are correct. If you wanted to go the other direction and convert from Fahrenheit to Celsius, then it's Fahrenheit minus 32, that entire quantity divided by 1.8. One easy calculator error is not to do this part first and just to put it all into your calculator without parentheses. So really make sure that you're watching, that you take your Fahrenheit minus 32 and divide the entire quantity by 1.8. Or multiply it by 5/9 depending on which equation you prefer. I will give you the equations on a test or quiz. You're going to need to know how to use them. Okay, let's look at a few examples of Fahrenheit to Celsius. And then, of course, the last one we have not looked at yet is Fahrenheit to Kelvin. Okay, so on a summer day, the temperature in the laboratory as measured on a lab thermometer is 28 Celsius. We want to express this in Fahrenheit. Okay, so this is the equation we're going to use. We're going to plug in our Celsius value, get Fahrenheit. Okay, and all we do is plug in our number, so 1.8 times 28. That quantity plus 32 gives us 82.4 Fahrenheit. Now, technically, if we were rounding significant figures, we would round to the 2, and this should be 82 Fahrenheit. Okay, because remember, we're going to base significant figures on what we're given in the problem. Okay, let's look at an example going the opposite direction. So it says on a very cold day, the outside temperature is negative 40 Fahrenheit. Express this temperature in degrees Celsius. So now I'm going to use this equation, plug in my Fahrenheit, subtract 32, take that entire quantity and divide it by 1.8. If I do that, I end up with my first part is negative 72, because I've just done this part, and then I'm going to divide it by 1.8, and I get negative 40 Celsius also. So this is kind of that point where they're the same before they start moving apart again, and so it's kind of just a weird fact that negative 40 Fahrenheit is also negative 40 degrees C. Kind of interesting. Okay, so let's review the formulas real quick. We're going to go Kelvin to Celsius and Celsius to Kelvin, Fahrenheit to Celsius and Celsius to Fahrenheit. Okay, the only one that we have not talked about yet is how to go from Kelvin to Fahrenheit. And like I said, I will give you these 4 equations on a test or quiz. You're just going to need to know how to use them. If you want to go from Kelvin to Fahrenheit or the other way around, there is no direct conversion. So what's your middleman here? What's the degree or the temperature that's present in every single conversion? Okay, well, hopefully you were thinking Celsius. Okay, because Celsius is present in the conversion to Kelvin and the conversion to Fahrenheit. So if you want to convert between Kelvin and Fahrenheit, you're going to have to go from one of them to Celsius to the other unit. There is no other way. You would have to do 2 steps. Okay, so try some of these conversions. Okay, and just pick a few. If you feel pretty confident, you don't need to do them all, but I would especially try this one for sure, because that's going to go, and then maybe this one too. That one's going to go from Fahrenheit to Kelvin. Okay, and then we'll go over them in class. So you may want to pause it here so you can do those examples. But we're going to go on to density. Okay, so what is density? Okay, well, let's look at the question. So we want to know, what is heavier, a pound of feathers or a pound of lead? Okay, well, hopefully what you said was that both are the same, because they have the same mass, because we're looking at mass or heavier. But they do have different densities, and so we can look at which one is going to take up more volume, and because density is a combination of mass and volume. So density is the amount of matter present in a given substance, and what I'd like to think of density is the measure of compactness. Because something that is really dense is going to be very compact, whereas something that's not very dense is not going to be very compact. And so it's a combination of matter and volume. So the equation for density is mass over volume if we use symbols D equals M over V. Now again, I will give you the equation. You're going to need to know how to use it. Okay, so because the feathers and the lead have the same mass, they do have a different density, and so that is going to change their volume. And the feathers are going to have a much larger volume because they have such a small smaller density. Okay, they're not very compact. We can look at ways to determine the density of liquids and solids, and so we're going to look at examples of both. So first, let's look at determining the density of a liquid. Well, we know for density we need mass and volume. And on Earth, mass and weight are basically the same thing. So we're going to weigh a known volume of a substance, and that will give us a mass and a volume. Okay, so suppose a student finds that 23.50 milliliters of a certain liquid weighs 35.062 grams. What is the density of this liquid? Well, we know that density is equal to mass over volume. We know our mass is 35.062 grams. We know our volume is 23.50 milliliters. And if we divide, we get 1.492 grams per milliliter. Okay, keep in mind that the last thing we should do is look at significant figures. Here we have 4 significant figures. Here we have 5 significant figures. So our answer should have 4, and it does, and we have units. Okay, so those are both very important things to do at the end of your problem. Okay, and like we just talked about, don't forget significant figures. Okay, now let's talk about how to determine the density of a solid. There are lots of different types of solids out there, and so one of the easiest ways to determine density of a solid is by volume displacement. And so we submerge the solid in water, or any liquid really, and measure the volume of water that gets displaced by the solid. That'll give us the volume. It's pretty easy to determine the mass of a solid, and then we can put those together to get density. This procedure is used to measure a person's percent body fat. There are lots of other ways that you can measure it also, but this is one of them. And so what they'll do is put you in like a pool of water and see how much water gets displaced. And then they use a lot of calculations to determine body fat because fat is less dense than muscle. So based on your mass and the amount of water you displace, they can tell you your percent body fat. Now, and this is going a little off tangent, but it's not just about weight, it's about overall health. So a muscular person weighing 150 pounds is going to have a smaller body volume and then a higher density than maybe someone who has a higher percent body fat. So even though they both weigh the same, we could probably argue that the muscular person is more healthy. So it's not just about weight. It's definitely, exercise, eating habits, all that stuff. So there's my little plug for being healthy. And now we can go back to density. Okay, so example 1. A student buys a medallion that the store owner assures is pure platinum. The student wants to be sure, so she weighs the medallion and finds its mass to be 55.64 grams. She then places some water in a graduated cylinder and reads the volume as 75.2 milliliters. So that's the volume before she has put anything in it. And it doesn't have to be an exact volume. She just filled it with some water and read the volume. Okay, next she drops the medallion into the cylinder and reads the new volume as 77.8 milliliters. Is the medallion platinum, which has a density of 21.4 grams per centimeter cubed, or is it silver, which has a density of 10.5 grams per centimeter cubed? All right, so let's find out if she got ripped off or not. Okay, there are basically 4 steps to problem solving, and I'm going to ask that you do these 4 steps because when problems get more complicated, it's going to be nice to have this system. So the first thing to do is write down all of your knowns and unknowns. And so we know that the mass of the medallion was 55.64 grams. We know that the initial volume of the water, so V sub I, was 75.2 milliliters, and we know that after she dropped the medallion into the water, it went up to 77.8 milliliters. And we are looking for the density, because if we know the density of the medallion, we can compare it to the densities of platinum and silver. And density is a physical property, so it's not going to change for the element or the material, so that's kind of a nice thing you can use it to compare. Okay, step 2 is to write the equation. So our equation is D equals M over V. It's already rearranged to solve for what we're looking for, so we don't need to do any rearranging. And so then we can go on to step 3, which is to plug in your numbers. And so density equals mass, which is 55.64 grams. Now the volume here is a little tricky because this is a solid and we use volume displacement. This is actually mass divided by the volume of just the medallion. And in order to get that, we have to take V final minus V initial. And so V final is 77.8 milliliters minus 75.2 milliliters. Now you could have done this bottom part separately and then plugged it in. That's fine too. Okay, and then number 4 is to get your answer with the correct significant figures and units. And so if we take 55.64 divided by the quantity, 77.8 minus 75.2, we get that our answer is 21.4. Now we need to do units. Well, grams are on top, milliliters are on the bottom. Okay, we probably should have given ourselves a few extra digits, but let's double check. It looks like we have 3 significant figures total, and since we're dividing, our end is going to be based on smallest number of significant figures, so 21.4 will work, and so that's our answer. Now if you remember the densities, this is close to platinum, and so the shopkeeper was correct. So she didn't get ripped off this time. Okay, let's take a look at a second example. Mercury has a density of 13.6 grams per milliliter. So as I'm reading the problem, I'm going to write down all of my knowns and unknowns. So density is 13.6 grams per milliliter. Okay, these are basically glorified story problems. So it's really nice to be able to pull all the information out so that you don't have to go back into the problem to find it. Okay, it says what volume of mercury, so we're looking for volume, must be taken to obtain 225 grams of the metal. So mass is 225 grams. Our second step is to write the equation. Well, this is the one that I know, but it's not rearranged to solve for volume. So I'm going to go ahead and do that. I know I want to get it out of the bottom, and so I'm going to multiply both sides by volume. So that leaves me with volume times density is mass. If I divide both sides by density, that gives me volume equals m over d. And now I've got it rearranged so I can just plug in. So volume equals mass, which is 225 grams, divided by density, which is 13.6 grams per milliliter. If I calculate that out, that gives me 16.54. Okay, now there's the tricky business of units. So let's take a look. We have grams on top, and that's kind of like grams over 1, divided by grams per milliliter. So I basically have a fraction over a fraction. Well, the easiest way to get rid of a fraction over a fraction is to multiply by the reciprocal, which means to flip it. I have to do it to both sides, because remember, I can't really change anything. Well, that cancels out everything on the bottom. My grams cancel on top, and that leaves me with milliliters, which makes sense because this is a volume measurement. So now I need to look at significant figures. I have 3 here. I have 3 here, so I want 3 in my answer. The 4 is not going to change the 5, so my final answer is 16.5 milliliters. Whoops. Okay, so what I would like you to do, and we kind of just did this, rearrange the density equation to solve for mass and for volume. So you should have mass equals and then some equation, and then volume equals and some equation. And we'll go over those to make sure that everyone's doing them correctly. All right, have a good day.